Section 8.2.2, how can I write it in simpler form? So again, in this section, we're looking at exponents, specifically exponent rules. In the previous lesson, you expanded expressions written with exponents into factored form and then rewrote them in a simpler form. You also looked at ways to rewrite very large numbers in scientific notation so that you could compare them more easily. In this lesson, you'll continue to develop ways to rewrite expressions using exponents. So let's look at the questions below to help focus your study. What part of the expression is being raised to a power? What are the factors? How can we rewrite the expression to have fewer terms? Okay, the first problem that we're going to look at is 8-59, and it asks you to rewrite each expression below in a simpler form. You can pause me right now and try it yourself, and then I will rejoin you when you push start again. Okay, so you've tried this yourself, and now we are going to do it together. So we're going to rewrite each of these expressions below in a simpler form. So the first thing that we can do is we can try some of the shortcuts that we learned last time. So if we look at the base, so in this case, it's a base 10 with an exponent of 2, and then we count up other terms that also have the same base. We can see that this 10 is of the same base. Now, because it's just 1 10, we know that's 10 to the first power, because this one is 10 times itself twice. This is 10 times itself only once, so 10 to the first power. So we could take the 10 and the 10 to the second power and the 10 to the first power and make that 10 to the third power, because we learned in the last lesson that when we're multiplying together exponents that have the same base, all we have to do is add the exponents to get the simplified exponent. So down here with x to the third, there's only one term with x as the base. And so we'll just add that, x to the third. And then we've got a y here, and it's all by itself. There are no other y's, so it's just y. All right, so that's one way of doing it, using the rules that we learned in the last lesson. But we can also factor. So remember the expression, when in doubt, factor it out. So we're going to use factoring so that we can check the answer that we got by using the rules we came up with last time. Okay, 10 to the second power is 10 times 10. So 10 times 10, 2 times. X, so that will be times x to the third power. So that's x times x times x. X 3 times itself. And then, of course, we have the 10, or 10 to the first power, which is 110. And then we have the y. So all of these are multiplied together just as they are all multiplied together up here. Now we're going to look at them and count them up. So we've got 1, 2, 3 tens. So that will be 10 to the third power. We've got 1, 2, 3, 3 x's. So that's x to the third power. And then we've got the y. So we just tag that on to the end. So let's compare that to that. We can see that we got the same thing by factoring as we did by using the rules and adding together the exponents when we're multiplying the bases. Okay, let's look at the next one. So this is 20 to the third power times 20 to the eighth power. And we know from the last lesson that since they both have the same base, which is 20, that we should be able to just add together the exponents, 3 and 8, and then get the answer, a simplified version of 20 to the 11th power. Let us also do this by factoring. 20 to the third power is 20 times 20 times 20. And then we're going to multiply that by 20 to the eighth power. 20 times 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 20. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yes, that's 8. Okay, so now we count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is equal to 20 to the 11th power. And that matches up with what we got by using our exponent rules and adding them together. All right, the next one. So let's see, the base of x, there's also another one with base x. So x to the second power, x to the third power. If we add the second and the third powers together, we get the fifth power. 2 plus 3 is 5. And then we've got a y to the second power. We don't have any other terms with the base y, so it's just y to the second power. And then we've got z to the second power and z to the fifth power. So if we add those two exponents together for the z base, we get 7. All right, let's factor it out and see if we get the same thing. X to the second power is x times x. Y to the second power is y times y. Z to the second power is z times z. And then we're multiplying x to the third power, x times x times x. And z to the fifth power, z times z times z times z times z. 1, 2, 3, 4, 5. Okay, so now let's count them all up. X's 1, 2, 3, 4, 5. So that's equal to x to the fifth power. Y, there are only two y's, so y to the second power. Z, 1, 2, 3, 4, 5, 6, 7. Z to the seventh power. All right, and that answer matches up with this one. All right, so just remember, you can use the rules as a shortcut, but when in doubt, factor it out. Now we're going to look at the next problem. So look over to the left again, and the next problem is 8-61. Aaron wants to rewrite the expression 5 to the second power times x to the second power times 5 to the fourth power times x to the third power in simpler form. She started by expanding the expression like this. So apparently that was her way of factoring. And the simpler form she got is right here. So do you agree with her work so far? Work by yourself or with your team to complete the problem. And if you do not agree, then write Erin a note explaining how to correct her work and find the correct simplification. Please put me on pause and I'll rejoin you in a minute after you've tried the problem. Okay, so you've tried this problem yourself and you probably were able to figure out that Erin was incorrect in her approach. So Erin, instead of keeping the multiplication between all these terms, which we see up here, because we know that when two terms are simply side by side, that means that they're really being multiplied together. And then this obviously says multiply these terms times these terms. So when we go down and look at what Erin did, she did factor 5 to the second power correctly, but then instead of saying that it multiplied times x squared, she put a plus sign. So she did factor x squared correctly, but then again, she put a plus sign in the middle instead of multiplying. And she did factor 5 to the fourth power correctly, 5 times 5 times 5 times 5. Then she made the mistake of adding x to the third power instead of multiplying it. So that's why she got the result here that she did, because she added instead of continuing to multiply all these terms together. So if we were going to tell Erin what she did wrong, we would say that Erin, you need to multiply all the terms instead of adding some of them. All right, and the way that we would find the correct simplification is, well, we could look at the bases. So there's 2 that are base 5, and the exponents are 2 and 4. So if we look at the bases, so base 5, 2 plus 4 is 6. And then we could look at the base for x to the second power times x to the third power. We would add together the exponents and get x to the fifth power. And then let's just check that by factoring. So if we factor 5 to the second power is 5 times 5. And then we'll multiply that times x to the third power, which is x times x times x. And then we also have to multiply 5 to the fourth power, which is 5 times itself 4 times. And then x to the third power is x multiplied times itself 3 times. Then if we count up the 5s, we'd get 1, 2, 3, 4, 5, 6, 5 to the sixth power, and 1, 2, 3, 4, 5, 6, x to the, oh, I added in one too many x's. Okay, it should be x to the second power, 1, 2, 3, 4, 5, x to the fifth power.